Okay, YouTube, in this video we're going to focus on a method of solving a system with matrices that's named after a German mathematician, Carl Friedrich Gauss. And so Gaussian elimination is the name that we give to this method for solving a system. But let's recall that really our goal when solving a system of equations like this is to write it in an augmented form, write our system in an augmented form, kind of like if we had these systems here, write them as an augmented matrix, but then put them in what we call this row echelon form, which we've described row echelon form as being this form where our matrix, at least, that represents our system has ones down the main diagonal and zeros underneath it. So what this is this is like the surefire way to always be able to write your matrix in that form using the row operations that we explored in the last video. So we're going to look at this as a process here, but I think that taking you through this entire table here in the first place would be most beneficial if we did it on an actual example. So one thing I do want to mention here is we could go ahead and start by reading the first part, is that we always write the augmented matrix for the system of equations that we're dealing with. So we're going to start with that, and then we're going to say using matrix row operations to simplify the matrix to a new row equivalent matrix in row echelon form. There's a lot of writing here. Basically, we want to make a new matrix that has the same solutions as the original. That's all we mean by row equivalent. And we want it to be in row echelon form, which is this ones down the main diagonal and zeros underneath. But in order to do this, use row operations to simplify this matrix into this row echelon form with ones down the main diagonal from upper left to the lower right and zeros below the ones in the first and second columns. Basically, in order to get it into this form, we're going to use this process right here. So the first step is always going to be this. No matter what you do, let's always get a 1 in the upper left-hand corner. So here's what I'm going to do. Before we even read any further, let's just go ahead and take a look at the system that we see right here, in which I'm asking us to use matrices to go solve it. So step 1, let's go ahead and start with this. We are going to write our augmented matrix, which would be 3, 1, 2, and 31. We'll put our vertical bar here. And I would say that it'd probably be a good idea if you would actually write small, because we're going to rewrite this quite a few times here. So we have 1, 3, 2, and 25. So now our goal is to get a 1 in the very top left corner here. So with respect to what we're allowed to do with our row operations here, here's what we know. We can switch row values, okay? We can scale a row by some non-zero constant, and we could scale a row and dump it onto another row. So if we want to get a 1 in the top left corner, I would say that the easiest way to go about this is probably just to switch some of our rows around. So I'm inclined to say that what I want to do is switch 1 and 2. So the way we're going to illustrate this is, let me go back here. We're going to redraw our matrix, but our row operation, not a list on the outside, is we're taking row 1, and we have to declare this that we're switching it with row 2. So now that we've declared this, let's go ahead and rewrite row 1, which is row 2's former values here, 1, 1, 2, and 19. We're going to put that in row 1. And then the second row here would become 3, 1, 2, 3, 1, 2, and 31. And our last row would just stay 1, 3, 2, and 25. 2 and 25. So here's our new matrix, and we've gotten a 1 in the top left corner. Now, going back to our steps, once we get a 1 here, it says use the 1 in the first column to get zeros below it. So what we're really meaning here is this. Because now that we have a 1 in the top left corner here, to get zeros below it, what we'll do is we'll take 1 times a number that when we take it times that number and add it to a positive 3, we would get that 3 to become a 0. And likewise, we would take 1 times a number that when I add that number to our positive 1 down here, makes it become a 0. So in other words, what we're going to do is we're going to make a little note here. We're basically going to use this 1 in the first column to get zeros below it, but we're going to do this by multiplying. Here's our technique. Multiplying that 1 by the opposite of the coefficients we're trying to cancel. Coefficients that we're trying to eliminate. I really can't write this in here very well because I just don't have a lot of room, but on your paper you could get that in there. Trying to eliminate. So essentially what I want you to know is that once you get a 1 in that top left corner, that's beautiful, because if I said, well, what could I take times a 1 to get to cancel out with a positive 3? I'd say a negative 3. And what could I take times a 1 that when I add it to a positive 1, I get it to cancel out? It'd be a negative 1, the opposite of this 1. So the way we're going to do this, I'm going to move this in a little bit here just so I have some room, is we're going to do two different row operations at one time. But we're going to say that let's take this 1 times a -3 and then add it to row 2. So to write this, what we would say is because we're affecting row 2, let's write it in front of row 2. We're going to take -3 times row 1, and we're going to add that on to row 2. Likewise, we're going to take now, to get this positive 1 out of the way, we're going to say let's take -1 times our 1 here in the row 1, and we're going to add that on to row 3. So we're going to perform both of these tasks at once, but the neat thing about it is row 1 just kind of stays the same. So we get 1, 1, 1, 2, and 19. Well, 1, 1, 2, and 19. So now we're going to have to think through this here, and this would be a good time if you need a calculator to kind of help you through this. So what I mean by use a calculator is grab a calculator, and what we're going to be doing is this. We're going to take -3 times all the entries in row 1 and add it to row 2. So I do this one at a time. I say -3 times +1 plus -3. So on a calculator, this is really silly. Suppose we could type this in. We'd say 3 negative times +1 in the first row, and we're going to add that to a +3 in the second row. We should get a 0 here. Now looking at -3 times this +1 here, okay, that'd be -3 plus 1. We would get -3 plus 1 is -2. And again, checking this on a calculator. Here's what I'm encouraging you to do. Take -3 times 1. So we say 3 negative times 1 equals, and then just say plus 1. You could always get this right. Again, I'll just leave this out. We say -3 times this 2. So we'd say 3 negative times 2. Okay, we get this, and then you add it to 2 in the second row. So plus 2. We get a -4 here. So -4. And then back to our calculator, we say -3 times 19. So we say 3 negative times 19, enter. And then we're going to add that to the 31 that was in the second row. So plus 31. Actually, it was -57, sorry. -57 plus 31. We get a -26. So a -26 here. So this is after carrying out this task onto row 2. Now let's take -1 times row 1 and add that to row 3. That's going to get rid of this +1 down here. So if we took -1 times this +1 on the top row, we get -1, and -1 plus 1 is also 0. Now looking at this next spot here, we say -1 times the 1 here in the first row, that'd be -1. So we get 1 negative times the 1 here in the first row, and then we're going to take that and add it on to the 3 in the last row. So plus 3 in the last row is 2. So we get 2. Now we'd say -1 times this +2 in the first row. So using the calculator, we say -1, -1, 1 negative times a +2 in the first row. And then we're going to add that on to this 2 that was in the third row. So plus 2 in the third row, that would make this a 0. And then we'll say with the calculator still, we'd say let's take -1 times our 19 in the first row. So really we get 19 negative, and then we're going to add that onto the 25 in the last row. We basically get a 6 here. And so here's what I want you to see. We just started by getting a 1 in the top left corner, usually by switching rows if you can, and then get zeros underneath it. That's the first step of getting this in the row echelon form. What you'll see here is that once we get a 1 with zeros underneath it in that first column, then the next goal is to get a 1 in the second row, second column position. So I want to get a 1 here. So going back and looking at this work that we have right here, I'm saying I want this right there to be a 1. So how can I get this to be a 1? What the goal is going to be basically is we're going to take this whole second row times the reciprocal. So multiply row 2 by the reciprocal of first non-zero value. In other words, our first non-zero value in this row is -2. So what we're going to do is we're just going to take our entire second row times -1/2. By doing this, anything times its reciprocal is going to be 1. So I'm going to go ahead and fill in all this stuff we didn't mess around with. The 1, 1, 2, 19, the 0, 2, 0, and 6. But the second row, if we take -1/2 times 0, we get 0. -1/2 times a -2 is a +1. And we would say -1/2 times a -4 is a +2. And -1/2 times a -26 is a +13. So you can see that this is always going to be as simple as, let's just multiply by the reciprocal of whatever term was here before, and that would make this a +1 right here. So now that we have a 1 there, going back to Gaussian elimination, what it's going to say is use this 1 now. We're going to use this 1 the same way we used this 1 here to get everything underneath it to be 0. So to get this thing underneath it to be 0 here, what we're going to do is multiply that 1 by the opposite coefficient of the coefficient we're trying to eliminate here. So when we look at this here, we'd say, well, I've got a 1. What's underneath it? A 2. So what can I take times a positive 1 that when I add it to the positive 2 cancels out? Well, it'd be a negative 2. So what I'm going to do is I'm going to grab this, and usually I wouldn't have all that writing in the way, but I'm going to yank it up here, and this is something that I would usually do, is draw a little arrow to take me back up here. But basically, what we can see is with our augmented matrix, we're going to take this row 2 times negative 2 and then add it to row 3 so that the thing underneath our 1 here in our second row, second column cancels out. So we're going to say negative 2 times row 2, and we're going to add that onto row 3, so we're going to write it in front of row 3. This means that rows 1 and 2 didn't change. 0, 1, 2, 13. So now our last row, the neat thing about this is, and even with the calculator you can see this here, if we were to take everything in the second row times negative 2, 0 times negative 2 would be 0, and you add that to the 0 below it, basically you're still going to get a 0 here. And if you were to say, let's take this 1 now, positive 1 times a negative 2. So we say, okay, well, let's take a negative 2 times a positive 1. You get a negative 2. And we're going to add that on to this row down here, this second row, third row, second column entry 2. You would get 0. So now we've gotten this to be a 0 underneath it just by doing the same technique we used over here when we had a 1 in the top left corner. And then for this last couple set of values here, basically, let's do this. We would say negative 2 times our 2 here. So we say 2 negative times 2. And we're going to add that onto this entry here. It was 0. So if we add that plus 0, we get a negative 4. So we get a negative 4. And then last but not least, we have to take our 13 here times this negative 2. So we'd say, okay, so we got 2 negative times 13. And we're going let's try that again. 2 negative times 13, negative 26. And we're going to add that onto the 6 in the last row. So we get a negative 20 here. So up until now, let's kind of recap what we've done. We got a 1 in the top left and used that 1 to kick out everything underneath it. And then we got a 1 in this second part of our main diagonal and used that 1 to kick out everything underneath it. So now the last part of Gaussian elimination is going to be, let's get a 1 here. Let's get a 1. Want a 1. So looking at this diagram here, it says, well, get a 1 in the third row. We're basically going to multiply that third row here, this negative 4 times its reciprocal, because anything times its reciprocal is 1. So just kind of carrying this down over here, let's go ahead and rewrite our matrix. Basically what we're going to get is this. We're going to take the entire third row to declare this first of all times a negative 1/4 because that's its reciprocal. So our first row, 1, 1, 2, 19. Our second row is 0, 1, 2, 13. And then our third row would become 1/4 negative times 0 and 0 would be 0 and 0. We get a 1 here when we take negative 1/4 times a negative 4. And negative 1/4 times a negative 20, that would be a positive 5 here. And so, behold, here's the thing. After you get this, you have this in row echelon form. And the reason why this is great is because we wanted to use this matrix operation to solve this system. So if we were to rewrite this system, assuming that we have an x, a y, and a z column, and these are our constants here, then really we would have had a system that said 1x plus 1y plus 1z is equal to 19. Also that 1y plus 2z's is equal to 13, and that also that z in the last equation has to be 5. So if this is our system here, let's go ahead and write our solution a couple different ways. First of all, the solution here, okay, the z value would be 5 in our order triple, or we could just say, hey, you know, guys, z is 5. But at the same time, we say, well, now that we know z is 5, whoops, this is y plus 2z is equal to 13. What we'll do is we'll just take that z value, we'll plug it in for the value of z, we say this is a 5. So now we have y plus 10 is 13, and we have the fact that y must be 3. So putting a box around this and filling it in on our order pair, now we know y and z. We'll go plug this back into the first equation, and the first equation here, oops, this is a 2 here. I just noticed this is a 2. We would say that would have been bad. We'd say x plus y plus 2z is equal to 19 here, and so we would get x plus a y plus 2 times z is 19, where in this case we would say that y is 3, and then our z value is 5. Plugging these back in, we get x plus 3 plus 10 is 19. In other words, x plus 13 is 19, and so we can conclude x plus. We could say that x is equal to 6. So I'll put a box around this. We say 6. So our solution here is 6, 3, 5. Now, in terms of this process, this took a while to do here, but I want you to know that this process, this like waterfall process where you get a 1 and use the 1 to kick out everything underneath it, and then get a 1 here and use that 1 to get everything out underneath it, and then get a 1 here. This would happen with equations that had 4 variables, 5 variables, 6 variables. We could do this every single time in a standard way, but it always gets us down to row echelon form where we could use back substitution to solve for the variable values. So we'll do this a little bit more efficiently in the next videos going forward. Cheers.